Kia ora, Year 11 and 12. This is the first question I'm doing from this year's calculus paper. So this is question 1E. And if you read it carefully and think before you launch in, hopefully you'll see that it's not too bad for an excellence question. We've got two equations here. We've got g of x and h of x. And g of x is a cubic and h of x is a quadratic. And we know, straight away from that, we know the shape of those two curves. Because it's x cubed, it's going to go up, down, up for the first one. And the second one is going to be a quadratic. And we're told that those two graphs just touch when x is equal to -1. So they have a common tangent at the point of contact. So that tells us two really useful things. First of all, we know that g of -1 is equal to h of -1. And because they just touch, they don't cross over, that means that the tangent line where they meet is the same one. And that means that the gradient must be the same at those 2 points. So the next thing we can write down is g dash of -1 is equal to h dash of -1, right? So this is coming from the fact that there's a common tangent, and this is saying there's a point where those two graphs meet. And if you look at the two equations, you can see that we've got two unknowns, a and b, and we've got two bits of information. So that means that we're going to set up a system of simultaneous equations, two little simultaneous equations, and we're going to solve those to find a and b. And finally, we're going to use that to find the coordinates of the point of contact. But we already know that the x coordinate is going to be -1. So all we're really after is what's the y coordinate. So I'm going to do the algebra and then I'm going to show you using GeoGebra what the graphs end up looking like. So let's start out by differentiating, because it's a calculus exam, so we should do that to get going. So g of x is x cubed minus ax squared plus 6. G dash of x is 3x squared minus 2ax. Often we'd set that to 0 to find a stationary point, but we're not interested in that here. Right? So h dash of x, let's start with h of x. H of x is 2x squared plus bx plus 13. So h dash of x is 4x plus b. And we know that at -1, these two things are equal. So g dash of -1 is equal to 3 times -1 squared plus 2a. So that's 3 plus 2a. Similarly, we can find h dash at -1, and that's going to be equal to -4 plus b. So equating those two things, we get 3 plus 2a equals -4 plus b. I'm going to make b the subject here because I suspect that's going to be a clean way to proceed. So we get 7 plus 2a is equal to b. Now let's go back and look at the condition we had first, which is that where is the point of contact? So at x equals -1, these two things are equal. So g of -1 is equal to x cubed, -1 cubed, minus ax squared plus 6, which is -1 minus a plus 6, or 5 minus a. And h of -1 is equal to 2, I'm just trying to find my equation, 2 times -1 squared plus b times -1 plus 13. That works out to be 2 minus b plus 13, or 15 minus b. And now we're going to equate these, because we know that there's a point of contact there. So 5 minus a is equal to 15 minus b. What do we get here? Well, let's make a the subject. Oh, let's leave it like this. -a is equal to 10 minus b, or a is equal to b minus 10. I'm doing this a very slow way, sorry guys. It's a plus 10. I must need another coffee Sunday morning. So b is equal to a plus 10, but up here, b is equal to 7 plus 2a. So 7 plus 2a is equal to a plus 10, giving me A is equal to 3 and B is equal to, what am I doing? B is equal to, I had this in my head. Oh, B is equal to 7 plus 2A. Of course, so B is equal to 13. So we're just about done. We can now go right back to the start of my question. We've found A and B, so we're very, very happy at this point. And we can chuck the A and B back into those equations because we're trying to find the coordinates of the point of contact. Right, so g of x is equal to x cubed minus, what was A? A was 3, minus 3x squared plus 6. And now I can work out g of negative 1, which is negative 1 minus 3 plus 6, which gives me 2. So the point of contact, or I could use h to do that as well. So the point of contact is negative 1, 2. Now don't turn off the video yet because I just want to show you what it looks like. So here are the graphs. This is the first graph, this is the cubic graph, and this is once I've put the A in. This is the quadratic graph, and when you put them together you can see that it works. Right, so looking at it here, here's my point of contact there, and you can just about see the tangent line through there. Thanks for watching. I will do the other excellence questions quite soon.